Okay, so in this video we will talk a little bit about oxidation-reduction reaction. And I have here an order of alkane, alkyne, alcohols, aldehydes, and carboxylic acid. And I have the zero pointing from an alkane to a carboxylic acid. As we walk to this way, we have the increase in the number of oxidation. As we walk backwards from the carboxylic acid to the alkane, we have a reduction. Remember that an oxidation of a carbon, as defined in your book, says that corresponding to the increasing number of bonds between carbon and oxygen, and the decreasing of the numbers between bonds between hydrogen and carbon. So I have here one example where we can see that the increased number of hydrogen and carbons we are decreasing the numbers between carbon and hydrogen bonds in this particular way. So here this carbon has 3 bonds with hydrogen, while this here has only 2, 1. And in this one here, we now is increasing the number of bonds between carbon and oxygen. So here we have 1, and here we have 2 bonds between carbon and oxygen. Here we have 2 plus 1, 3. So as we increase the number of bonds between carbon and oxygen, and as we decrease the bonds between carbon and hydrogen, we oxidize our molecule. And the reverse, as we increase the number of bonds between carbon and hydrogen and decrease the number of bonds between carbon and oxygen, then we reduce our molecule. So always remember, oxidation happens from the alkyne to the carboxylic acid. Reduction happens from the carboxylic acid to the alkyne. So if I have an example where I have an alkyne and I'm making an alcohol, I know that I'm oxidizing that particular carbon. And if I have an example that I have an aldehyde and I'm going backwards to an alkyne, then I'm reducing that particular carbon.